understand part 2. At first, I am going to give you some idea about the formula that will be required to solve the numericals. So, first one, formula for uniform speed. Uniform speed can be denoted by symbol V, and uniform speed is equals to distance covered, which can be denoted by symbol S, by time taken. Okay, so what is the formula for uniform speed? Distance covered by time taken. Then second one, uniform velocity. Uniform velocity is also denoted by symbol S, and uniform velocity is displacement by time taken. Is displacement by time taken. So first formula is uniform speed, second formula is uniform velocity, and third one is for average speed. Average speed is calculated by dividing total distance covered by total time taken. Total distance covered by total time taken is the formula for average speed. So, first one, formula for uniform speed, distance covered by time taken. Second one, uniform velocity, displacement by time taken. Average speed, total distance covered by total time taken. But you should know, to solve numerical, you should know the SI units. SI unit of, if I ask you speed or velocity or average speed, the SI unit is meter per second. You can also write like this, meter second to the power minus 1. Okay. Now, if I ask you what is the formula for average velocity, formula for average velocity is total displacement by total time taken. Total displacement by total time taken. You should note down these formula properly. This will help you in solving numericals. Now I am going to discuss about the concept of distance and displacement, and this will help you in solving numericals related to distance, displacement, speed and velocity. So, distance and displacement. So the concept, first you try to understand the meaning of these two terms. A person moves from A to B, and the length of this irregular path is supposed to be 20 meters. Initial position is A and final position is B, and if I consider a straight line path between the initial and final position, length of this path is supposed to be 10 meters. Then this 20 meters is called the distance covered by the body, and this 10 meters is called displacement of the body. So what is distance then? Distance is the length of the actual path covered by a body, and displacement is the shortest straight line path between the initial and final position of the body. Okay? So I am going to discuss different cases here. First case, if a body moves in a straight line from one position to another. If a body moves in a straight line, straight path from one position to another, in this case, distance covered is equals to displacement. Actually, the magnitude of distance covered is equal to the magnitude of displacement. This length is supposed to be 10 meters. So if I ask you what is the distance covered, 10 meters. If I ask you what is the displacement, 10 meters. Look at another case. If a body moves in a straight path from A to B and returns to position A along the same path. So started from A, ended at A. In this case, if I ask you what is the distance covered? What is the distance covered? You can write the length of AB plus the length of BA, or you can write length of AB plus AB, or it is twice AB. Is the distance covered? But if I ask you what is the displacement of the body, displacement will be 0. Why 0 displacement? Because the initial and final positions are the same. Now look at here for another case, case 3. This case I am discussing about circular path motion, or motion of a body in circular path. If a body moves in a circular path and completes one round, let the radius be r. We are discussing for one round. अगर एक बॉडी सर्कुलर पाथ में मूव कर रहा है और वन राउंड इट हैज कंप्लीटेड, इन दिस केस डिस्टेंस कवर्ड क्या होगा? डिस्टेंस कवर्ड क्या होगा अगर यहां से स्टार्ट किया और यहीं पे पहुंच गया इस पाथ से? दैट इज इक्वल्स टू सर्कमफेरेंस, एंड सर्कमफेरेंस ऑफ द सर्कल इज 2 pi r. So formula for distance covered for circular path for one round 2 pi r. And if I ask you what is displacement, displacement is 0. Why? Because the initial position and final positions are the same. Now another case, case 4, I am going to discuss about semi-circular path. What kind of path? Semi-circular path. If a body moves in a semicircular path of radius r, if a body moves in a semicircular path of radius r, in this case, if I ask you what is the distance covered? फुल सर्कल में डिस्टेंस कवर्ड था सर्कमफेरेंस 2 pi r. सो हाफ सर्कल में डिस्टेंस कवर्ड होगा हाफ ऑफ सर्कमफेरेंस, एंड हाफ ऑफ सर्कमफेरेंस दैट इज हाफ इनटू 2 pi r, दैट इज pi r. देन व्हाट विल बी द डिस्प्लेसमेंट? What will be the displacement? Displacement will be, this is the initial position, this is final position. So displacement is the straight path, and this is equals to diameter of the circle, and this is 2r, where r is the radius. So this concept will definitely help you in solving numericals related to distance, displacement along with speed, velocity, average speed. Okay, so first case here, if a body moves in a straight path, distance and displacement are the same. If a body starts its journey from a point and moves in a straight path and returns along the same path to the original point, then distance covered is, the length of this path is doubled here, and displacement is 0. For circular path, for one round, distance covered is 2 pi r and displacement is 0. For semicircular path, distance covered is pi r and displacement is 2r. You should note down these formula, these concept properly so that you can solve numericals easily. Now I am going to discuss one of the important conversion that will be required in almost all chapters of physics in class 9. And here we are going to discuss that to convert kilometer per hour into meter per second, that is SI unit. Kilometer per hour is bigger unit. And how to convert the speed or velocity given in kilometer per hour into meter per second. Look at here. I am explaining with the example here. For example, I am considering the question here, convert 72 kilometer per hour into SI unit. 72 kilometer per hour into SI unit. So we can write like this: 72 kilometer per hour is equals to 72 kilometer upon 1 hour. We know that in 1 kilometer 1000 meters, so 72 into 1000 meter, and 1 hour will be 60 into 60 seconds. Some students make this mistake. They write 1 hour is 60 seconds. So you should memorize that 1 hour is 60 into 60 seconds. In 1 hour 60 minutes. To convert minutes into second, you have to multiply by 60. So here if you do the simplification, 12 here and twice, so it is 20 meter per second. But I already told you in the part 1 of chapter motion that we can also convert this in another way, or here 72 kilometer per hour is equals to 72 into 5 by 18 meter per second, because 1000 by 60 into 60 is 5 by 18. तो एक्चुअल में यहाँ पे हम लोगों ने क्या किया है, 72 को 1000 से मल्टीप्लाई करके 60 into 60 से डिवाइड किया, और 1000 divided by 60 into 60 is nothing but 5 by 18. So here 18 4 ja, so 20 meter per second. So I discussed how to convert kilometer per hour into SI unit, that is meter per second. You should note down this part properly and then you focus here. Another example I am going to discuss here, the conversion is related to how to convert meter per second into kilometer per hour. I am considering the example, convert 25 meter per second into kilometer per hour. To convert 25 meter per second into kilometer per hour. So look at here, 25 meter per second. We can write like this, 25 meter upon 1 second. This 25 meter, if you divide 25 by 1000, you are converted 25 meter into kilometer. 25 by 1000 is 25 meter. If you divide that by 1000 is 25 kilometer. And to convert second into hour, 1 by 60 into 60 hours. If you simplify it, 25 by 1000 into 60 into 60 by 1 kilometer per hour. So here we can cancel these zeros. Now 25 into 36 divided by 10 kilometer per hour. On doing further simplification here, 2, 5, 18, so we'll get 90 kilometer per hour. So if you convert 25 meter per second into kilometer per hour, you will get 90 kilometer per hour. But another short method I'm going to discuss here. 25 meter per second is equals to 25 into 25 into here we multiplied by 5 by 18 and now 18 by 5. 18 by 5 kilometer per hour. So it is 5, so it is 90 kilometer per hour. Okay, so we have discussed the conversion here, important conversion to convert kilometer per hour into meter per second or to convert meter per second into kilometer per hour. So after discussing the basic concept, now we will solve numericals. I will discuss many examples. One I will solve for you and I will give you one similar question that you will have to solve yourself at home. So we are going to start solving numericals one by one. So the first question, a car covers 3 kilometers in 2 minutes. A car covers 3 kilometers in 2 minutes. Calculate the speed of the car in SI unit. So here distance covered is given, time taken is given, and you are asked to calculate the speed of the car. Look at the solution here. In this question, distance covered is given, it is 3 kilometers. Since we are asked to calculate the speed in SI unit, you should know the SI unit of speed and that is meter per second. So हम लोग को करना क्या है, distance को मीटर में convert करना होगा. 3 kilometer is 3000 meter and time taken is given here. Time taken is 2 minutes. 2 minutes 120 seconds. So now you'll have to calculate the speed, and you know the formula for speed. Speed is equals to distance by time, or distance covered by time taken. Distance covered here is 3000 meter and time taken here is 120 seconds. Okay, now simplify this. 6 here, 150 here, and if you cancel you will get 25. So it is 25 meter per second. So it is one of the simplest numerical where we are asked to calculate speed, and we know the formula, speed is equals to distance by time, and we got the answer. It is 25 meter per second. Question number 2 for your self-practice at home. The question is, a truck is moving with a speed of 54 km per hour for 5 seconds. Calculate the distance covered in SI unit. For your convenience, answer has been given. Try to solve properly. Now we'll try to solve question number 2. And the question here, a train is moving on a track with uniform speed of 20 meters per second and covers a distance of 4000 meters. We have to calculate the time taken by the train. So here, if I ask you what is given here, uniform speed is given. We can use the symbol for uniform speed as V. V is given here 20 meters per second. And the distance covered, S, is given here 4000 meters. And you are asked to calculate time taken. We know the formula. What is the formula to calculate the time here? You know that formula for uniform speed is equals to distance covered by time taken. Distance covered by time taken. Distance covered here is 4000 meters. Uniform speed is given here 20 meters per second, and you are asked to calculate time. So T is equals to 4000 divided by 20. Since we are calculating time and we have taken all other quantities in SI unit, the SI unit of time will be seconds. So it is 200 seconds. 200 seconds. So time required by the train is 200 seconds. Now question number 4 for your self-practice. The question is, a rocket moves with uniform velocity of 108 km per hour. The velocity is given here. And for 2 minutes, calculate the displacement in SI units. So here, velocity is given, time is given, and you are asked to calculate what? Displacement. For your convenience, the answer is also given. It is 3600 meters. Question number 5 we are going to discuss. Question number 5, look at the question here. A body moves in a circular path of radius 7 meters and completes 1 round. Calculate the distance covered and the displacement. So the body moves in circular path. And radius is given. Radius is 7 meters. And the body completes 1 round. Suppose started from here and stops here. The path is circular, and here if I ask you what is the distance covered, we know in circular path in 1 round distance covered will be 2 pi r, where r is the radius, and the radius is given here. Radius is 7 meters. So 2 into 22 by 7 into 7 meters. If you simplify it, you will get 44 meters. Now the next part, if it is asked what is the displacement? What is the displacement of the body? Displacement will be 0. Why 0? Because the initial and the final positions of the body are the same. So displacement will be 0 in this case. Should note down it properly. Now we can note down question number 6, which is for self-practice. Question number 6, a body moves in a semicircular path of radius 7 meter. Calculate number 1 distance covered and number 2 displacement. So in the question, the path is semicircular path. The path is semicircular path, its radius is given, and you are asked to calculate distance covered and displacement. Answers are given for your convenience: 22 meter distance covered, 14 meter displacement. Now we discuss question number 7, and the question given here: a person moves 3 km towards east in a straight line path and then moves 4 km towards north in straight path. Calculate the distance covered and the displacement. So person first moves towards east, and here the straight path, so displacement is 3 km, and second, the person moves 4 km towards north in the straight path, displacement is 4 km. So if I consider the 4 directions like this: north, south, east and west. Let the person moves from position A to B towards east, and the length of this path is given here 3 km. Then the person moves towards north, B to C, and here the displacement given 4 km. So if in the first part it is asked what is the distance covered. So here distance covered will be equals to length of AB plus length of BC. Distance covered is the length of the actual path covered by the body. Length of AB is 3 km and length of BC is 4 km. So it is 7 km. In the next part it is asked what is displacement, and displacement here, if you look at this figure, for displacement the initial position is A and the final position is C. So displacement is the shortest straight line path between the initial and final position, and this straight line path between initial and final position is nothing but AC. So displacement here will be AC. Now how to find the magnitude of AC? So here this is right angle triangle. If I use Pythagoras theorem, I will get AC square equals to AB square plus BC square. So AC square is equals to AB square, that is 3 km whole square, plus BC square, that is 4 km whole square. We can write. Now AC square is equals to 9 km square plus here 16 km square. Therefore, or we can continue here, AC square is equals to 25 km square. Therefore AC is equals to root over 25 km square. Therefore we can write AC is equals to 5 km. When you are solving for displacement, if possible, you should also mention the direction, because displacement is a vector quantity and vector quantities need both magnitude and direction for their complete expression. So AC is 5 km, and if you look at the direction here, AC is towards northeast. So we can write 5 km towards northeast. Okay, this is one of the most important numericals. You should note it down properly. Now you can note down question number 8 for self-practice. It is one of the simplest question. A person first moves from position A to position B in a straight path, covers 10 km. Then the person returns to the position C along the same path and stops after covering 3 km towards position A. Okay, the person returns to position C and moving towards position A and stops after covering 3 km. You will have to calculate distance covered and displacement. I am not going to give any hint for this particular numerical. You can try yourself. Now we will discuss question number 9. Question number 9, a train covers first 200 km in 2 hours and next 800 km in 3 hours. You will have to calculate average speed. And we already know the formula to calculate average speed. Average speed is equals to total distance covered by total time taken. So in this particular numerical, if you look at the solution here, formula for average speed, you already know it is total distance covered by total time taken. We can use symbol like this, S1 plus S2 by T1 plus T2. S1 is 200 km, S2 800 km. Distance first is 200 km, next part it is 800 km. T1, first part of time is 2 hours and the next part 3 hours. So it is 1000 km by 5 hours, and 1000 by 5, it is 200 km per hour. So what is the average speed of the train? It is 200 km per hour. Now you can note down the last question of this part, and this question is for self-practice. Question number 10, a car moves in a straight path and covers 150 km in 3 hours and next 250 km in 5 hours. So first 150 km in 3 hours, next 250 km in 5 hours, you are asked to calculate average velocity of the car. So you should know the total displacement, you should know the total time taken, and you can easily calculate average velocity. So students, in part 2, I have discussed some simple numericals related to distance, displacement, speed and velocity. In part 3, I will discuss some complicated numericals. I will also start the topic acceleration and retardation as well as related numericals.